everyone. Welcome back to our third webinar of the week, actually third webinar of this mini series. Again, my name is Ping and we have Thomas with us also. I am CEO of Optical Networks and Thomas is our sales engineer. I hope everyone's doing well, staying home, staying safe. Let's get on with it. Today we, again, those who have not joined us yet, we are targeting a 25-minute webinar. Questions, don't wait till the end, just ask away, type them into the chat box. We have someone in the background that will manage those, push them forward to us or hold them out to the end. But from your point of view, anytime you have a question, small or big, ask away and we'll get to them. There's a survey at the end of the webinar. Please fill it out. It helps us make sure that we are providing the right content, presenting it properly for you. And just like all the webinars, this one is recorded and it will be available on our YouTube channel, which is available here. Before we move forward, we have several more webinars part of this mini series already scheduled. Next one is Monday at 10:30 a.m. Pacific time, 1:30 p.m. Eastern Standard Time, and we'll be talking more about IP addresses, DHCP, and the difference between dynamic and static IP. Okay, those who've joined us in the last couple webinars, we've often related back and talked about how there's a lot of similarities between networking and the postal system or the parcel delivery system. We used the example of if Thomas went on Amazon right now and ordered a toilet paper, it would go into a box. So toilet paper is the payload, and it will be wrapped around different layers, and then you'll have a to address and a from address. Very similar to that. Now, today we're going to talk a lot more about VLAN and subnets. And before we go into that, it's important to understand the difference between a unicast communication and broadcast communication. Unicast is when something is sent one-to-one. Thomas sending me a letter. When Thomas orders toilet paper from Amazon, that's unicast. It goes from one place to one person. Broadcast will be just like what we are doing right now. We are broadcasting my voice to many of you in the postal system. That will be your advertising, right? One entity orders advertising to be shipped from one place to many places. And just like in networking, the postal system also separates these into communities or different regions. So one delivery person would deliver that to a set of houses, apartments, a region, and that's the same thing in networking. So now we're talking about subnets and VLANs. Just before I pass it over to Thomas, one important thing that I want to remind everyone is that a layer 2 network, if you just connect a bunch of switches, you went to a store and you bought a managed or unmanaged network, and you just connected a bunch of equipment, that would be a flat network, one network. And if a device sends out a broadcast, it reaches everything. So if you start creating a very large system, let's say thousands of VAVs or thousands of security camera, the problem with that is that a device that sends out a single broadcast will now send it to all other devices. And if every device sends a broadcast message every second, let's say, and there's 1,000 devices, it means that every second there's 1,000 more packets on there that's reaching everything. And again, we will talk about this in a much later webinar in detail, but often when we say the network is slow, it's not that the network can't keep up. It's the fact that devices are connected to a network and the devices can't keep up. So if every device connected to a flat network, it's connected to 999 other devices, and it has to process 999 messages every second, that is really not necessary. You are using CPU cycles and buffer in the device that really is not necessary. So let's now, if everyone understands that a flat network is very simple, but the danger of flat network is that now broadcast messages go everywhere. How do we get around that, and how do we make that more manageable? So that brings us to today's topic. Thomas, you're up.
Perfect. Thanks very much, Ping. Yeah, so as mentioned there, or in some of the previous presentations we're given, you have a router, let's say, separates your WAN from your LAN, keep your local area network local. But often you might have, as being said, a large number of devices or a large number of users on that local area network, and you might want to divide that up further. So there are two ways of really doing this. You have your layer 2-way and your layer 3-way. The layer 3-way is subnetting. So that's taking your IP address, taking your IP address and breaking that up. So you might know a subnet mask. So your subnet mask is when you have your IP address that is going to consist of 4 sections of numbers between 0 and 225. The mask is how many of those numbers represent your network and how many of those numbers, how many of those numbers represent your host addresses. So you'll have a number of different networks. The most common one you'll come across, we have see here on the slide, is the /24. So that's one we usually recommend because it keeps things nice and simple. Your class C address, your /24, means that the first 3 quadrants are going to be your network and the last quadrant is going to be your host address. That will give you 254 hosts that can you work on a network. So it is that's just general subnet mask in your network and your host. So then subnetting, you can break that up further, but we have you'll see here we have our different kind of addresses. We have our different subnets. So in a /24, we have 192.168.1. That then we have the .2 and the .4. Under /24, they're all totally separate networks. Now we also can use a /22 as you see here. The reason we recommend staying with /24 is that it does make things easier when you just have the first 3 quarters are for your network and the last quarter is for your host address. But you can change this up and down, and the /22, /20, what these mean is 20 or 22 bits of that IP address are representing your network and the other bits are representing your hosts. The more bits /22, 22 bits are used to define your network. That means you actually have 2 more binary bits for your hosts, which is doubling the amount and doubling it again. So you have 4 times the number of possible hosts in a network now. So it's just a matter of if you want to make it bigger or smaller, or if you want to divide it up, you can make that much smaller if you had like small sections. But you might have, let's say, in an IT network, so you could have accounting, you could have sales. In an OT network, you could have lighting, you could have security cameras, you could have doors, and you might want all this traffic to just be separated and not to be broadcasting, not to be updating each other. Obviously, our cameras don't need to know when the update from the lights. So we like to keep these segregate individual tasks and individual appliances and kind of keep everything to its own plane so that things aren't interrupting each other or things aren't listening or hearing or getting congested to the traffic on a different area by specific by things that aren't relevant to other things. So just trying to divide it up and how we divide it up.
Yeah, so just summarize, there's a lot of detail here. Monday, we will talk more about IP addresses. I think we will dive a little bit more into the zeros and ones and how a 24-bit mask applies to all this. But just summarize what Thomas is saying here. First of all, there's 2 ways of writing this. It really is 100% equivalent. The shorthanded way, we put a /24. But often when you go to router, you go to your device and you enter IP information, what they call the mask will not appear as a 24 number or a 22 number or even a 32 number. It will show up as 255, 255, 255.0. So 255, 255, 255.0 is equivalent to 24, 100% equivalent. We'll talk more about that on Monday, and /22 is equivalent to 255, 255, 252. We'll talk a little bit more about that on Monday again, but in advance, this is like understanding IP addresses and how all this maps is basically a 1-day course. We would have to break it down all the way to binary, build it back up to understand octets and all this stuff. Just like Thomas is saying, if possible for you, use 24-bit mask, 255, 255, 255.0. That will simplify things. Of course, if you need subnets that are a little bit bigger, then reach out to us. We'll help you get there. /22 is probably the best number to use in these cases. Anything bigger than that, you're creating subnets that are a little bit too big, and we come back to that problem I was talking about earlier.
That's right.
To give you an analogy also here, because we're going to talk about VLAN in a second, Subnetting is, imagine yourself in a large auditorium and there's 5,000 people in it, and you want to have breakout sessions. You could have groups of people go into different corners of the room and have manageable size conversation, 50 people, 100 people conversations. That's kind of the idea of subnets. And what I mean by that is that you're focusing on each other. You're really only listening to that group of person you're working with. But if you step back, you can still hear the noise from everyone else. Okay, so subnets is that analogy, and we'll explain the second step of that. But think of subnet as in, if you have a large auditorium, that's a large network, and you're splitting it up into manageable group of conversations, and you're really only listening to the people in your group. And that's your network address. Your 192.168.1 would be a group ID, and then the .0, the last one, or /24, that could be groups of up to 254 people speaking at once. Okay, so subnet is a layer 3 concept. Let's go to layer 2.
Sure. So VLANs are virtual local area network. So it's just another means of segmenting the network, but is definitely a much can be easier to adjust and kind of change. So the way this works is actually a tagging system just to be able to kind of partition your network. So the way this would work is the port of which a device is connected. You'll put a tag on that port saying any information that comes in through this port, that's being shown us here now, any information. So we take, for example, we'll take one of these doors. You have it's connected to a switch here, and you would actually have a rule on that switch saying any information or any talking that is done through this port, we're going to put a tag on it saying tag 2, and then that's only going to be able to communicate with other devices in the local area network that also have the tag 2 communication. So it'll only be able to, you can also separate that further. But if you would have your doors here, you can see the two of them. They're obviously on one door is on the same switch as a few lights, and one door is on the same switch as a few cameras, but they're not going to be able to communicate with one another, although the IP addresses might show devices that are all on the same network. So just another means of dividing it up without having to get into the IP addressing, the subnet masks, and making sure it's all configured that way, which can be a bit easier, a bit more flexible as well, because if you decide to plug a device out, plug another device in, you can quite quickly change the port. I think it's 3 lines of configuration, and you'll have your port switched from one VLAN to another VLAN. Now it just keeps everything, as you say, everything nice and together. You have also rules. You can see possibly here, if you see in the center there, we have our aggregation switch. You're going to have trunk. So possibly you want to get into access and trunk ports. So a trunk port will be a connection between 2 switches, which can allow multiple VLANs across. Thanks for mentioning. So it allows multiple VLANs across, and an access port will only allow will only allow one VLAN, so you have to tag that. What you can do here is with trunk ports, you can say how many VLANs you allow traffic to flow through, so how many VLANs you will allow on here. So if we did have a situation like the one shown in front of us, we have these 2 security doors. Now, as you can see, above and below, there's 2 switches, and they have security doors connected. To the left of our controller, we have a 3rd switch. There's no security doors connected to that. So we could actually have a rule on our trunk connecting the leftmost left switch back to our controller, but that's only going to have trunk allow VLAN 10 and VLAN 30. So no traffic will come across. So you can just segregate everything, stop certain bits of traffic, so certain broadcasts being even heading that direction. So if you had information being sent around, you won't even have anything coming from the doors going that direction at all, and it can just help divvy things up, make sure that things are separated. Yeah, no, I think with them there, it seemed you have it's all just kind of partitioned up. Sorry, there now, but I think that'd be almost most of it there. With the VLAN tags, they're quite simple. I think if we go down to the next slide, there, we have a few things on the configuration.
Yeah, just a quick comment on this. I think if we take a moment and think about the history of VLAN and appreciate where that came from, it can also help understand this. So VLAN was first created because we were creating separate networks for different services, right? So your AV people will come in and put in a full network, its own wires, its own rack, its own switches. And then the IT people will come in, or actually accounting people will come in and build its own network, and so on and so forth. So you would have these duplication of hardware, and would cost a lot of money. VLAN was originally introduced so that we can leverage a single hardware platform across multiple services. And that's where this VLAN concept came up. So you say, okay, well, I'm going to install one large switch. I'm going to use these ports for accounting, these ports for lighting, these ports for AV. And it makes it work exactly the same as having 3 different switches in this example. So if I come back to the auditorium story, subnet will be isolating people, sorry, not isolating, pushing people to different corners and having individual conversations. But if you step back, you can still hear the noise. VLAN will be putting up walls, right? So once you have VLAN, there's absolutely no communication that can cross from one VLAN to another VLAN unless you allow it to. So when you combine them together, you can really manage these large conversations.
And it's as these things grow and scale that they really become, you get to take advantage of it. So it's obviously with a smaller network and smaller devices, these aren't as big problems. But as things grow and you get large, even enterprise or just solutions or designs, this is when it really, you'll see the advantages. You'll see it's really going to help optimize your network and prevent any congestion or unnecessary utilization of your bandwidth. As we had mentioned as well, just in the previous slide, it's very easy kind of just when it comes to, if you were to go to CLI interface, it is only 4 lines. Sorry, so after you're getting into configure terminal, you get onto your configure your interface, get onto config if, and then you just change the switch port mode to access, and then access VLAN 5. So even at that, it's a bit of, you will have to get onto CLI, change that. But from our Optical One view, this is almost done with just 2 clicks. It's very simple. You click on your VLAN mode, you have access there, and then you have your tags on each port. You can just click on them. Here we have management 1, we have HVAC. You can literally just double click that, and you'll be able to change it. So it is something that is very easy. Just you're changing the token, the tag at which the port is that is associated with the port when the information comes in, and that can be changed. So if you do CLI, it is once again quite easy, but especially with the One view now, it becomes just click of a button. You can have different things changing to different areas. You can be plugging things in and out without having to worry too much about the repercussions or the config time that is involved with it. And finally, then we have a large, or so we have just a bit of a more built-out network with using the One view. So as you can see here, we have a hybrid system set up here. So we have a few daisy chains. These look like some 4 ports and some 16 ports, and going to a larger, more industrial 8-port switch. So you can see there's a number of different things that we can have connected there. Once again, we can have our lighting, and they're very much quite separated. If you look through switches or the amount of connections they're going through, it's quite a number of things that if there was a broadcast, if there was something that they would be, you can see a lot of other devices listening would be hearing in on this and would be getting affected by it. So it is just once again a nice handy way of having it. You would have your network here, you'd have your computer, your laptop when you're using connect to your One view. This will all be in the one interface or in the one GUI. Especially now, if you see we have a new router that is actually available as well, or that will be coming out, we'll be offering soon. That will actually also be included in the One view GUI, and that will allow just for that you can maintain actually layer 3 functionality as well. So it will allow for communication between these VLANs if necessary, or if you wanted, to allow for also some other features that maybe not as necessary here, but allows for only one IP address required from IT, and then you can actually do some netting, some DHCP of your own. So it just allows for things like subnetting and VLANs, where often you might need a router or something to allow for communication between them. This is something that is available now, and it's something that Optical have are planning on releasing.
Yeah, thank you, Thomas. So to summarize, if we step back, think of your large system, your overall system, right? Lighting, HVAC, security, access control, internet access, VoIP, all these things. You could create one large flat network, but first of all, you would have so many devices connected to it, that you would have a lot of noise on the network, which would reduce the performance of the connected system, right? In many cases, your network will still be able to keep up. I mean, most networks are now 1 gig, and unless you're connecting a lot of information, you typically have enough bandwidth on the network to handle it. But it's the devices that are connected now, it has to listen to so much noise. So use IP subnetting and VLAN to separate it. Another fantastic reason for doing it is security, right? So that the devices connected on your CCTV network cannot see the information that's being exchanged between your VoIP network. And so 2 main reasons for it is to separate it into manageable size and to separate them for security reasons. And VLAN's like putting up walls. Once the VLAN is in, it cannot see any data from other networks. Whereas if you only use IP subnet, if you change the IP address of that device, you could hear the information for other subnets. So you combine them together.
Another reason I should spill on that with the security or with the way you can do it is an often common thing is to have a default VLAN or so, make that what we consider the garbage VLAN. That until a device is connected and we intentionally decide to put it on a VLAN, every free port is effectively connected to nothing. It's in a VLAN by itself with no information, no sensitive data. And so you would have to knowingly put that port actively on a VLAN before anyone can do anything.
Yeah, we do have 2 questions, but before I just jump to the questions, a couple comments. Unmanaged networks, sorry, unmanaged switches cannot set up VLANs. Okay, so that's one big reason for not using unmanaged switches. There are many things we'll talk about over the next couple of weeks that are not supported in unmanaged switches or networks in general. So question 1, does VLAN segmentation put more stress on a router than planned subnet arrangements? I think the question, so in short, yes, you have to design your subnets properly, or else you will put extra strain on your routers that's not necessary. So for example, if we say, hey, out of simplicity, we're going to put every building on its own subnet, but there's a lot of communication between buildings for whatever reason, then that communication has to go back to router to exchange between them. You could use layer 3 switches also to do that. But yes, planning your subnets properly. And in general, you want to separate it so that those conversations are mostly localized and reduced inter-subnet communication as much as possible.
As you were saying there, you're a virtual local area network. So effectively, as far as you're concerned, you are in a different local area network to them. So you do want to make sure you're not separating things that would want to stay in the same network or required to be, because once it's designed, it might as well be in a separate network altogether.
Yeah. Second question. In BACnet, if say we have 2,000 devices, breaking it into subnet, does it help? Because BBMDs are forwarding broadcast traffic to other subnets? Assume you need to share data between subnets. So unfortunately, the answer is no. As soon as you break it into subnet, the BBMD is required, unless you don't need to exchange broadcast information. But in general, and someone please correct me if I'm wrong here, in general, BBMDs will forward all broadcast traffic. So it actually does not reduce the amount of broadcast traffic. If you do plan your BBMDs properly, and the BBMDs only forward to the right place, then yes, the BBMDs will reduce the amount of broadcast traffic. But if you say every subnet has a BBMD and every BBMD can speak to every other BBMD, every BBMD has other BBMDs in its whitelist table, then it doesn't actually reduce the amount of broadcast traffic in that case. But if you do design it right, so I think in large systems, very often there'll be 2 layers of BBMDs. We'll forward it to kind of a core BBMD, and the core BBMD would then forward it back to others. In that case, managing a broadcast will be well done, but you do have to design it properly. Hopefully that answered both questions. If you have more, we are here. Again, an easy way to reach us is writing to us at support@optigo.net. If not, we do our next session is Monday at 10:30 a.m. Pacific time and 1:30 p.m. Eastern time. Again, thank you very much for joining us. If you have any comments, suggestions, please reach out. If there are topics you'd like to hear, if there are speakers you'd like to hear, let us know. We are here to help us get through this crazy time right now. Take advantage of us all being at home to learn a little bit more. With that note, stay home, stay safe, take care of each other.
Thanks, guys. See you then. See you Monday.